Hi, I'm Praveen. I'm an applications engineer at Cypress Semiconductor. In this video, I'm going to show you how PSOC 3 can measure thermocouple temperature to an accuracy of 0.1% or 0.5 degrees Celsius, whichever is greater, at room temperature with a one-time calibration. So here is the setup that I'll be using for my demonstration. I have the project in my laptop. This is the PSOC 3 development kit. The kit 025 PSOC precision analog temperature sensor EBK is connected to it. It has a thermocouple connector that doesn't have a thermocouple right now. We're going to use a voltage source to simulate a thermocouple. The voltage source is the board that you're seeing right here. It's powered by the USB of the laptop so that the grounds of the two systems remain separated out as required for a thermocouple system. And I have a 6.5 digit multimeter that's 0.025% accurate as my absolute reference source against which I'll be benchmarking my measurements. After programming the device, let's press reset. After pressing reset, the menu shows clear indications on the directions for calibration. If you do not press switch 2 within 3 seconds of pressing reset, the device doesn't calibrate and directly shows the uncalibrated reading. The uncalibrated reading in this case is 49.010 millivolts. That is actually the reading in the second row. Let's check what is the value on the standard multimeter. The standard multimeter reads 49.046 millivolts. That's a difference of approximately 30 microvolts. Now let's see what calibration can do to it. To calibrate, press reset. Now follow the instructions shown by the LCD. If you don't press switch 2 in 3 seconds, it's going to show the uncalibrated value. So I press reset again. Press switch 2. Now I have to apply 0. So I apply 0 volts. To continue, press switch 2. Now I apply full scale. Full scale is the accurate voltage that I'm applying. In this case it's 49 millivolts I'm applying from this low noise DC source. Once I set the voltage to a proper value, I press switch 2. Now the device shows the gain calibration constant and the offset calibration constant. To save these values in the EEPROM, press switch 2. Now the values are stored in the EEPROM. Continue, press switch 2. Now the device is calibrated. Let's see the performance of calibration. So here we see the calibrated accuracy. If you see PSOC, it shows 48.945 millivolts, and the standard source shows something similar, 48.946 millivolts. I'm just going to focus both of them in the same frame, and we see that the voltages are very close to each other with a difference of approximately 4 microvolts at the maximum. There is a small variation in the output flicker on the LCD. That's because the input is not very stable. The same flicker can be observed in the multimeter too. Let's go across and change the input voltage to some other value and check how the reading goes. So I vary the input to a very low value, around 0 volts. Now I see that The multimeter reads 0 volts and my input value is 4 to 5 microvolts. There's a small difference of 4 to 5 microvolts in this reading. Let's change it to a little higher value. I change it to somewhere close to room temperature, which is around 1 millivolts. Now, as you see, the multimeter reads 1.25. It varies a little because it takes some time for the potentiometer to settle down. From the look, you can say that both the LCD and the multimeter are very close. They have a difference of around the maximum of 6 to 7 microvolts, which is at the maximum point 2 degrees Celsius. Now I increase it further to somewhere close to 16 millivolts. The reading closely follows again. The potentiometer reading takes a while to settle down. It actually decreases continuously because the potentiometer is not very stable in a fixed point. You can see that the value has stabilized a bit, and both the values are approximately the same. The maximum difference of 4 microvolts. I'll increase it further. .35 millivolts. Take a while to settle down. Let's just wait for a while. So it's approximately 35.56 millivolts. The value is the same in the LCD too. It closely follows the reading in the multimeter. Now I increase it to 50. Greater than 50 millivolts. It's 53 millivolts in this case, 52.8 millivolts, and the reading here is also very close. It's not significantly different either. Now, from this calibration, we've shown that calibrated accuracy is less than 0.1% or 0.5 degrees Celsius, whichever is greater. Thanks for watching the video.